Ramesh is here and Gopi is here, right? Okay.
Okay. Okay. Good morning, everyone. It gives me immense pleasure to welcome you all for Professor S. Chandrasekharan's platinum birthday. It is a joyous moment for all of us. Wish it could have been a physical meeting. However, this pandemic has forced all of us to meet virtually. Nevertheless, we are all here. I think it has given an indirect opportunity for all of us to connect to the various part of the world in spite of the different time zone. I think this is another way I can say it has just blessing in a disguise for all of us. So it did not pull out our opportunity. I thank you all for joining in spite of your busy schedule, maybe a different time zone. Thank you. Thanks a lot. Like today, we are celebrating our distinguished Revered Professor S. Chandrasekharan's birthday. It's a very small event, though, but then we have planned it in a very sweet manner. I thank each and everyone, the distinguished scientists over here from different parts of the institutes, our students, our seniors, juniors, well-wishers from different part of the academic as well as industrial section. And I will welcome you all once again. I'm wishing you very happy Deepavali, a festival of light. In Sanskrit, the teacher or the guru has many meanings. One of the meanings is guru, which says gukarasya andhakareti rukarasya prakashati. Gu is symbolic, the letter gu for the darkness, and the ru, the letter symbolizes a light. The teacher is the one who brings light, means who brings the knowledge and dispels ignorance or dispels darkness. The light is which has presence, whereas the darkness doesn't have presence at all. And our Professor S. Chandrasekharan has made a huge difference, not only for the students, many in the part of life to dispel the darkness and to remove the ignorance and bring the knowledge. We all agree that all the students they have a great potential to grow and glow, but then we are like a coal, and we need a teacher to attach a sparkness or a small light, and then all of us can grow and glow. And indeed, sir, you have done a great help in our educational and professional career. And undoubtedly, it is a joyous moment for us, and we are presenting a very small function to you as a dedication. I once again thank Jayanti ma'am, Jayanti madam, Jayanti Chandrasekharan to join, and everyone to join and grace this event, including Professor Chandrasekharan, who is the most important person for all of us today. And I thank his family members, Ramya and his family, her family, Arati and her family, and welcome you all. And over to Shiva for the further program. Without further ado, thank you.
Thank you very much, RGB. So after I speak after RGB, there is nothing left. He is always ahead of everything in wishing and then starting the program very nicely. So happy birthday, sir. We are very happy that we are celebrating together, being so far away. We wish we are in Bangalore and celebrate this. And I think everybody would have been very happy to come and wish you in person. So I'm sure that we are going to do this over the full year 2021. We are going to celebrate your birthday with many other scientific lectures, dedication, and everything. And hopefully we will meet you soon to wish you in person. So without any further delay, so we will have our first session. So I ask Ramesh to start the session.
Thank you, Shiva. Good morning, everyone. So it's a pleasure to introduce the first speaker for today, Professor Tushar Kanti Chakrabarti. Although he does not need any particular introduction to this, or rather any audience in India, Professor Chakrabarti joined IIT Kanpur as an MSc student almost at the same time, and Professor Chandrasekharan joined IIT Kanpur as a faculty member. So he completed his MSc from IIT Kanpur in 1979, and then he did his PhD also from IIT Kanpur with Professor Chandrasekharan, and was the first PhD student to graduate from the group. He graduated in 1984, and then he moved to University of Pennsylvania and did his postdoctoral research with Professor Casey Nicolau. He returned back to India in 1987 and he joined IICT, CSIR IICT as a scientist C. And over the years, his research interests were in the synthesis of natural products, synthesis of unnatural amino acids and incorporating them into peptides, sugar amino acids, synthesis of sugar amino acids. And particularly, he is known for making macrocyclic systems which were otherwise not known. And by 2008, he rose to the rank of a scientist G. And in the same year, he moved to CSIR CDRI Lucknow as the director of the institute, where he stayed until 2013 as the director. And after that, he moved to IIC Bangalore, where as a professor in the Department of Organic Chemistry, where he's currently serving as a professor. Professor Chakravarti had an illustrious career. There aren't any major awards in India that he has not received. He received the Shanti Sujok Bhatnagar Award in 2002. He's a fellow of all the 3 academies in India. And he received the J.C. Bose Fellowship in 2008. So it's a long list that I can go on, but I do not like to do it today. I would rather request him to talk to us. Professor Chakravarti.
Thank you, Ramesh, for your very kind introduction, very long. And first of all, let me thank Ram and Shivapriya for very kindly giving me this honor to, open the innings. And it's always a pleasure to be with the SCN family members. And I mean, I wish we could have had, like a big celebration, like any other time. But, unfortunately, this is not possible at this time. But, other way, as Ram was mentioning that, or Shivapriya, that we can connect to people from all over the world and no time zone and barrier or any other issue. Today we are getting used to it, starting from, doing your shopping and teaching, or, ordering food, or, taking care of your research, all online, and including our birthday celebrations. And so maybe, that one way it is better. And as I have written, the title of my talk is The Journey as a Synthetic Chemist, which started way back in December 78. Can you hear, all of you?
Yes, please, go ahead.
And once again, very long and very happy to and be with us for many, many years to come. And you can all see that it was in July 78 semester that we got to know him more closely when he started taking our the laboratory course for the practical classes. And he was an instant hit with the students, and that continues even today. And so I remember, this was an unusual practical class. I don't know whether Ramesh and all are allowing these things or not nowadays. And we are asked that we could design any experiment. And so like some money was given to us. So we would go and buy, 1 kilogram of peanut and, learn how to extract the peanut oil. Or, then coffee, Kanpur, we could not buy coffee seeds those days. So we had to buy instant coffee and to, isolate caffeine from there. And we, ended up taking all the coffee, drinking, and then finally we got very little caffeine. Very little was left from the instant coffee, and whole lab used to smell of coffee. And then many other, beautiful experiments that we all wanted to do. Again, like isolating nicotine from tobacco. So we bought a lot of tobacco. And many of us, ended up smoking that tobacco, putting in filter paper and not getting, of course, enough nicotine at the end. And then, of course, isolate this compound, purify them, and then, characterize them and see the spectra and all those things. So it was very nice. And then first batch, I think 5 of us, we decided to do our MSc project in his lab. And that was kind of record, he was possibly 32 plus at that time. And he was more popular than many other senior professors in the department. And so out of 13, 5 students, we did our project in his lab. Somewhere did in the November end or December. we cleaned up the lab and started working from there. And now I've had like more than 42 years of my close association with him as a researcher, teacher, mentor, science administrator in the country. And I don't know how many thousands and thousands of committees he might have, chaired. And so he has been a role model for all of us. And we should never forget the support and encouragement. Of course, we all received from Jayanti also during this best part of our lives. And we used to have, wonderful dinner during our student days and a lot of sambar and idli and in our house. And my wife, card rice, Sushmita and my daughter, they joined me to wish Prof.SCN very long, healthy and happy life, and pray he continues to keep us his blessings and guidance to all his students for many, many years to come. And this is some picture I have shown earlier. So it is this famous molecule which is synthesized and in the lab, in the coal lab. And next picture is somewhere Vidya and then Milind. And Milind was doing his MSc project at that time. I just joined the PhD program. And this was in '86. I have shown this before. I can see Bhaskaran and some others. And I had visited, from Casey's lab. I was working at that time. I visited India, IIT, and that was the picture taken at that time. So from that time onwards till today, he looks always as happy as ever. And especially, with becoming the very proud, grandfather. So he is more happy nowadays. So this is the picture in his house. And my first project that I did was my initiation in organic synthesis, MSc project from December to April '79. And that time, I used to react pinacol with acetic anhydride in presence of DMAP, and we got cyclic carbonate and many other, products that we devised the mechanism of reaction. Even ketene was formed during the reaction, diketene was formed, and later on this became the part of Vidya's thesis, and we got a paper in JOC in '84. And my PhD work was on chromium reagents. So this is my first paper in TL in 1980, and I continued working on chromium reagent. But the best part of my work is shown here in this slide, where we first time, found out that you can cleave even double bond with chromium reagents. And so if you have a tertiary alcohol which does not undergo any oxidation, so you can get a lactone as shown there. And this was also published in TL. And later on, in chemistry later, the bottom part of this reaction that I have shown. There's a good anecdote on this story, because the first time I did that reaction, it was in summer in Kanpur. And summer in Kanpur in coal lab, the top floor used to get very heated up. You open the ether bottle, it will start boiling, and within no time ether will get evaporated. And doing columns with any solvent would have been very difficult in summertime. And this reaction was done in DCM. And when I started doing this work in winter, where room temperature was like a 10 degree, the reaction was not going. And so I was wondering why the reaction does not go. And then of course, I started refluxing. I remember that first time I did was in summer. And then of course, the reaction was going. And then, double bond was getting cleaved with the pyridinium chlorochromate or, the chromium 5 reagent as shown there. And the beauty of this reaction was that it is an iterative process. And I always liked to follow simple chemistry, so which can be repeated, and you can follow the 4 steps that addition of this butynyl magnesium bromide. I remember, we learned how to make even the, butynyl bromide. So I had to make 1,4-dibromobutane, and that was also not reported. Later on, I found that some people have reported this reaction, and I used to use HMPA without worrying about then how carcinogenic that HMPA was as a kind of solvent. And then you heat it up to some 200-degree temperature, and then butynyl bromide gets formed, and then it distills out. And very easy, if you have 1,5-pentane dibromo pentane, then you can do the same thing and you get a pentenyl bromide. And then you do the Grignard reaction, and followed by the PCC oxidation, so you get a lactone, spirolactone, and then you can do some rearrangement with the methane sulfonic acid in presence of P2O5. And This reaction actually was reported first by Dr. Sukhdev in Journal of Indian Chemical Society in 1957. So we followed that chemistry so that from the lactone that you get, you can form again a bicyclic compound after hydrogenation and repeat those 4 steps. So you can get, beautifully some triquinone type of molecules in polyquinone by repeating this process. You can get a 5-membered ring, you can get a 6-membered ring if you use, pentenyl magnesium bromide. So very nice, simple work, but it has a lot of possibilities. I think later on some more students in the lab had worked on this. And from there, then again, I finished my PhD in '84 and then went to work with Casey. And that was also Sir Chandrasekhar instrumental in getting me, because as I always, I was never sure of what I would do in my life. And always I needed a mentor like SCN to tell me what I should do. So he said, no, you should go abroad. And then he himself wrote to Casey. And then I went to his lab and worked on this synthesis of amphotericin B. And I was there for 2.5 years. Of course, as I have shown here, in between I came to India and visited Kanpur. And I also visited Casey's lab after my marriage. For a year I was there. Then we synthesized rapamycin using some, I think, stitching, double stillate cyclization kind of thing. And I came back and joined IICT, did a lot of synthesis like this kind of molecules in the lab. But one piece of work that I would like to show today is what we have been doing even now last more than 25 years. 2020, that was like a developed method we developed for making 1,3-diol system and opening from epoxy alcohol. So using titanium-3 reagent. And the reason for developing this method was that, we were interested to undertake the synthesis of a molecule like swinolide. And this is, of course, like a big molecule, but you can see that I was always, attracted to symmetry, not only in the molecules, but also in life. And this makes the life of the student easier because they have to make only half of the molecule, and then you can do dimerization to get swinolide. So the way we plan to do the synthesis was that you can do that the bisallylic alcohol, which method was developed by Schreiber using sharpless epoxidation to get this chiral epoxy alcohol. So we thought that we'll extend this to the tri-substituted epoxy alcohol. If you do tri-substituted epoxy alcohol, we did sharpless reaction, but then we could not open this epoxy alcohol using any hydride reagent. And we tried all possible hydride reagent to try to open this epoxy alcohol, but we failed. Then because of that, we developed this titanium-3 chemistry. And at that time, there's no method available to open tri-substituted epoxy alcohol selectively in the 2 position. Only very recently, Gunsauer from Germany has published this paper where they use some silane in presence of tetrabutyl ammonium fluoride, we can get 1,3-diol. But at that time, we thought of using titanium chemistry, and that worked very well. So you can see that you get a radical there, but normally radical reactions, you will say that it's not stereoselective, but we get a very selectively only one isomer when it undergoes like a proton quenching. And you can also like add radical quencher like acrylate and also get a quaternary chiral center. So we developed given the mechanism of how it goes to a cyclic titanium-4 intermediate, and then proton abstraction takes place selectively from one side. And both intramolecular as well as intermolecular quenching is possible, and we published many papers. We applied this method in the synthesis of course, this is the mechanism how it goes, that you get initially this titanium-4 system with the 4-membered ring, and then it goes more stable carbon radical and then gets quenched, and then finally you get 1,3-diol. And if you clip the work of the reaction very early, then you will end up getting like a allylic alcohol. So this reaction takes a little longer time, and as I have already given the mechanism why stereoselectivity was observed, and that was the mechanism we gave 1997. But very recently I found that Rajan Babu, who developed the titanium-3 chemistry first, and William Nugent and Gunsauer and many others have published a paper in Tetrahedron. It's kind of review article, and they have tried to find a fault in the mechanism after almost 20 years, what we have proposed. And one of the examples they have given that if you have a carbon derived epoxy alcohol as shown here, 66, if you do titanium 3 reaction and they get, these two compounds, and ideally speaking, if our mechanism was right, then you should have had a racemic mixture. But instead of racemic mixture, they were getting, some chirality where like a rotation was like a plus 114, and what the literature value for the pure compound was 210. So it has an enantiomeric ratio of 77 to 23. So if what they are telling that if this mechanism of the two oxygens are forming titanium 4 species, then it should have been formed in equal amounts, which does not form. And so they have proposed a mechanism that this hydroxyl does not take part in the formation of the cyclic intermediate. Instead, it's only forming the hydrogen bonding with this intramolecular hydrogen bonding, and so there is a distinction between the two oxygen, and you get one of them more. But anyway, I will not go into the details of this, but this has been very useful for us, and many polyketide natural products have been synthesized in our lab using this kind of methods, and where you can see that 1,3-diol systems are there. And one example I'll give, again, I'll not go into the details. So another cytosymmetric molecule, we undertook the synthesis. And this is the rhizopodin, is the actin binding, anti-cancer molecule, and it inhibits the polymerization of actin. And this, like a mechanism of action of this molecule, is also reported that it bridges two actin molecules together. And we undertook the synthesis. Two of my students started working, Kiran and Srikant. Srikant is now working in Bangalore in Biocon, and Kiran has joined as a faculty member in ISA Tirupati. So as usual, they have made this red color, there's fragments, the advanced fragment for this molecule, and these papers were published in Tetrahedron Letter 2011. And Srikant by that time left, so it was left to Kiran to complete the total synthesis. And so he prepared the one half of the molecule, which had to be dimerized. As shown here, you have a hydroxyl and the carboxyl group. And then, he published the paper in Organic Letters, because what happened that he tried the dimerization as we had thought of doing, but instead of undergoing dimerization, it underwent intramolecular electronization. And at that time, Casey also had published this paper. He also could not get it dimerized, so Kiran was worried. And so we went ahead and published this paper. And then Casey at that time wrote that he wants to have Kiran in his group so that he can complete the synthesis. But Kiran was very nice to me, so he stayed back in my lab and to complete the synthesis. And then since the dimerization did not work, so he prepared the linear dimer by standard procedure and then went on to make the macrocycle, and he published, and then he left, and then he worked with Casey's group, and now he is back in India. And this method that we have developed earlier for polyketide kind of a natural product in last 5, 6, 7 years, we have been working on making like a different kind of terpenoid molecules. Maybe the influence of the lab where I am working. So this is a small molecule, but structurally very challenging. And two of the molecules were synthesized by my student Dipendu Das. One is like a penifulvin, and one is like asparaculin. And these are like a what they call fenestrine kind of molecule. It's very difficult to synthesize, especially the chiral quaternary center in the middle of this molecule. But very efficient synthesis was developed by my student, and this was published also before he left. Then incidentally, he also worked with Casey and for 2-3 years now. And many other extension of this method, like we have made simple lactones doing this, intramolecular cyclization, doing some bridgehead molecules where you have a hydroxyl here by going through the silent chemistry and following by titanium opening, and many other like a indole-based reaction also were done and by my students in recent years. And one molecule that we are now trying to synthesize is like a panaginsin. So that also like a similar kind of molecule. And once again, you can see that we use the titanium chemistry to prepare the quaternary chiral center. And next slide showed, our work on the peptides, as Ramesh has pointed out, that we also somewhere in the middle of 1990s, like switched over to some new area where we designed, sugar amino acid, a multifunctional building block that can be used very efficiently for mimicking peptide secondary structures. And the first paper that we published on that one, where we introduced the sugar amino acid in enkephalin molecule, so leu-enkephalin, and so it introduced a structure in the molecule where two aromatic residues come close to each other, and that's the structure actually enkephalin takes when it interacts with the delta opioid receptors, basically the GPCR, which are on the cell membrane. And but in our molecule, that structure is pre-introduced in the molecule because of the sugar amino acid and because of an unusual hydrogen bonded structure. As you can see here, that NH is forming hydrogen bond with the hydroxyl, where normally in peptides, like a serine or threonine form hydrogen bond with the main chain carbonyl, but where hydroxyl acts as a donor. But in this case, hydroxyl is acting as an acceptor, and because of this pseudo 9-membered beta turn structure, and which has a strong hydrogen bonding, you can see that temperature coefficient. So this gave this kind of structure, and that was published, and we did a lot of work on this. As I said, like a peptidomimetics work, and then we made a C2-symmetric reversed and mimetic. Some of these molecules were tested for HIV protease inhibitory activities. We made also in the process some of the cyclic, like symmetrical molecules using furan amino acid, and they are strong G quadruplex binding ligand. We made cyclic homooligomer of these molecules. In many of these cases, as I said earlier, that we can do cyclodimerization, that you have to make only a smaller segment of the molecule and you can dimerize very easily in one shot to get these cyclic molecules. And so we worked on antimicrobial peptides. We prepared some glycoconjugates. We also tried to work on non-coding RNAs for therapeutic targets, and as I said, G quadruplex binding ligand. And one of those, we were interested to design analogs of gramicidin S. Gramicidin S, is a good, antibiotic, but of course it never became a drug in spite of, being known for more than 80 years now, because it is toxicity and it can kill the red blood cells. So hundreds of papers have come out on making analogs of gramicidin. So what we have done here, that gramicidin, you can see, has a D-Phe pro in the two ends of the molecule. This is also a cytosymmetric molecule, incidentally. And what we have done, we have developed the sugar amino acid as shown here at the bottom, which is a C6 substituted sugar amino acid we call. And you can have the stereochemistry as you wish. There are 3 chiral centers of the molecule. And this kind of side chain basically mimics the side chain of the diphenylalanine that you have in the natural gramicidin S. And my student went ahead and made all the possible isomers of this gramicidin, and we found out a lot of activities of this molecule. We also make the glycoconjugate work, as you can see here, that this homo-oligomers of this sugar amino acid gives very beautiful, robust 3-dimensional structure, and then we can append the sugar molecules at the end and find out their binding with the lectin and determine their conformation and all those things. Because there's a lot of application. One of these, I can show that urinary tract infection is caused by what do you call E. coli, and E. coli has a FIM-H, which is like a mannose binding adenosine. So when we used our molecules, so that prevented the E. coli from binding to the epithelial bladder cells, and so that showed a very good activity. And I'll not go into the details. We have published some papers on this in different journals. And then we have also been thinking of, mimicking the regular DNA RNA structures and using amide linkages. And this work, of course, is not new. A lot of people have attempted this, but we were the first to, synthesize this monomeric building blocks for making this amide mimic. And in all the 4 bases that RNA will have, AUGC, you can make the corresponding nitrogen protected amino acid, and then you can use standard solid phase peptide synthesis to make oligomers of this molecule. Depending on the sequence, whatever you decide to make, you can make it very easily. And my student Yashoda Krishna, So he developed the method, solid phase method, for making this molecule in solid phase. And so he prepared. It's a little difficult than normal peptide synthesis, because normal peptide synthesis, FMOC chemistry, at the end you cleave this molecule from the resin using TFA. But this method could not be used because a lot of these bases are labile to acid. For example, depurinylation takes place if you use TFA. So we had to really use a very mild method for cleaving this oligonucleotide from the resin. And later on, this was extended to prepare, for example, the seed sequence of MIR 21 as shown here. So most of the MIR, all these nucleobases that you have seen, they don't bind to the RNA. So it's the seed sequence, which are like 8 to 10 nucleotide long. They are the one which like a bind to the RNA for the biological action. So we prepared the seed sequence of MIR 21, and because MIR 21 is one of the most important microRNA, which is responsible for the metastasis and many other areas of cancer. So if we could make a mimic of this, and then it can suppress the MIR 21 activity, basically anti-MIR 21. So it can possibly show biological activity. We have not yet tested these molecules because I don't have any student nowadays who would like to work on this project. So we have the sample. So maybe someday we'll find somebody to test these molecules. So that also in the process, we have also studied the conformation of these amide-linked RNA mimics. And we find that when you put an nitrogen in the 3' position, it gives more like 100% N-type conformation in the sugar ring. And that we hope that can lead to the increased affinity towards the cognate RNA. So we have published some of the papers as shown here on this molecule. And I'll just stop here today, and whatever we have done, in life, and whatever I have learned, synthesis is because of these two people that shown here. And we are fortunate, all of us, to have blessings and good wishes and long association with Professor and Jayanti. So I once again thank you, and sir, for this you have made all these things possible in my life because of your constant support and encouragement. And I now stop here. I thank all my students who have worked very hard. And these are the 4 students at present I have with me at IISc. And I thank you all for your attention.
Thank you.
Thank you, Professor Chakrabarty, for a very inspiring lecture. And thank you for giving us a glimpse of everything that you've done over the years. So now I would request, if anybody has a question, I would request you to unmute yourself and tell your name and ask the question to Professor Chakrabarty. I hope you would be okay to give some, answer some of the questions, Professor. Okay. Are there any questions from anybody?
Ramesh, can I
Yeah,
ask
yeah.
one
Shiva,
question?
go ahead.
Yeah, very, very inspiring and very nice talk, Professor Chakrabarty. So I just wanted to know, in 89, when rapamycin synthesis was done, so other than knowing it's an mTOR inhibitor of mammalian, so was it foreseen that rapamycin would become such a blockbuster molecule?
Yeah. Actually, immunosuppressants were not known, earlier. And when I give talk to the general students, I tell, the first heart transplant took place in 1967. At that time, there was no TV or anything, we all read in the newspaper by Christian Bernard in South Africa. And then, everybody started speculating now, a human being can live forever because the only important organ in your body is like a heart, and if you can replace a faulty heart, so you can live forever. But the patient died within 1 week because there was no immunosuppression available. Then came cyclosporine, then came FK506, and then of course rapamycin. And mTOR plays very important role, not only in the immunosuppression, but many other, biological function. mTOR is a very important molecule. And of course, this is not only like a good synthetic target, but people have used this as a probe to find out, the biological, processes involved in the immunosuppression and many other things which are not known in the early 1990s. And it was very hot topic. And at that time, like everybody was trying, and of course, synthetically also challenging. And that was the work that we did, stitching cyclization in one step. We could make the final product of this molecule. And now I think it's a drug, I think, along with FK506, it's a regular immunosuppressant drug.
Yeah, but that's a wonderful paper that we would always present. We are actually presenting some important synthesis.
Yeah. Yes.
Thank you.
Yeah.
Any more?
Ramesh, do we have 1 minute time maximum?
Yeah, sure. I think you can do.
Thanks, Tushar, first of all, for accepting and giving a wonderful and lucid and interesting lecture. And you gave a overall overview. Maybe we were that time even babies, or some of us were not even born when Prof.SCN and you started the research work in IIT Kanpur. But anyway, you have talked much about his lecture. Even I have been inspired a lot by using different colored chalks on the blackboard for teaching. He has been a wonderful teacher for us. So I just want to have a very quick question. One on the the furan based amino acid, the cyclic peptides. So are they? The cyclic peptides are unnatural amino acid derived peptides, or they're available in the nature, especially the furan based amino acids?
No, furan-based amino acids are not known, but sugar amino acids are known.
Yeah, what made your group to think about furan-based cyclic peptides?
Yeah, basically, it again, I did not have time to show how we got into this, because we are designing some analogs of rapamycin. And if you see the structure of rapamycin, it has actually, unlike any other drug, which binds normally to only one receptor, these molecules bind to multiple receptors. So one side is known as a binding domain, one is like effector domain. So we try to synthesize the binding domain, and there, a tetrahydropyran ring is there. And it was difficult to synthesize. Then we analyzed that, can we have an sugar, like an amino acid kind of thing? So assembling this molecule, because at one time we have prepared some peptide tethered binding domain, so which binds to like FKBP12, but does not show immunosuppressant activity. And people were also very interested to find non-immunosuppressive immunophilin binding ligand. So which will not show immunosuppression, but it will bind to immunophilin like FKBP12 and things like that. So we are working on that. And at that time we thought maybe if you make an amino acid, then synthesis becomes simpler. Unlike organic synthesis is very difficult to make that kind of scaffold, because you can see that a rapamycin has a pipiculic acid, and you can have a then 6-membered ring. And when we started working, then Kessler from Germany published the paper on 6-membered ring. And so we gave it up for some time, and then finally we got in the 5-membered ring. And in fact, when we sent the paper, then they said this work is better than Kessler's work, because Kessler did not get biological activity. 5-membered ring gave the biological activity, and the paper got accepted in JSCS at those days. So that was the beginning. So we continued in 5-membered, but there are some 6-membered. People have done work on 6-membered ring, and even 3-membered. Some people have made epoxide-based, like a sugar amino acid kind of thing. So a lot of work has been done worldwide for this kind of molecule.
Yeah, very quick, another question. You talked about internal hydrogen bond, intramolecular hydrogen bonding, where kind of hydroxyproline kind of molecule and an amine. Yeah. So by any chance, introducing a histidine or somewhere, it would have been worked as a catalytic triad?
Yeah, we have not tried. We have a lot of time. I thought, but I could not get anybody to work in my group which can be used as a catalytic triad. I am sure it would have been possible. And one interesting thing, if I keep the hydroxyl protected, suppose OBN or something, so this structure is lost.
Yeah, that's
true. It does not form the hydrogen bond. Then it goes to the regular, like a beta tran, type 2 beta tran that proline or any other molecule will have. But when you have the hydroxyl free OH, then only it acts as an acceptor of the hydrogen bond. Yeah.
Thank you.
Maybe someday I'll find some good student, maybe who can do this organocatalytic reaction with this peptide.
Yeah. Thank you for giving a wonderful lecture, and thanks for joining us.
Sure, it was my pleasure.
Okay, so I think because we are pressed for time, we'll move ahead. So thank you, Professor Chakravarti, once again for a very nice talk.
Thank you,
before
Ramesh.
I hand over the mic to the next person, I would like to wish Professor Chandrasekharan a very happy birthday, sir, and many, many happy returns of the day. And after me, Gopi will now introduce the next speaker. Thank you.
Thank you, Ramesh.
Thank you, Ramesh. It was dot on time, 11:15.
Yeah, hi. Good morning, everyone. Before I introduce Dr. Balaji, sir, wish you many more happy returns of the day. Hi, sir, and hi, ma'am. Yeah, so it is indeed a pleasure to introduce Dr. Balaji, who is my very own junior, and we have a long history of together. He's also my good friend. Dr. Balaji did his bachelor's degree at Vivekananda College, Chennai. In fact, I did my bachelor's degree also there. And in fact, Prof.SCN is also an alumnus of Vivekananda College. We're happy to share that with you, sir. Yeah, so after completing his bachelor's degree, Dr. Balaji moved to IAC as an integrated PhD student, and close to a decade-long stay at IAC, he completed his master's and PhD. In 2016, he moved to work with Professor Masakatsu Shibasaki at the Institute of Microbial Chemistry, Tokyo, wherein he worked on asymmetric catalysis, exploring the chemistry of thiourea, chiral thiourea as ligands. And currently, he's working at the Institute for Chemical Reaction Design and Discovery with Professor Benjamin List. I think it's an overseas lab of Professor Benjamin List at Hokkaido University, Sapporo. Okay.
Yes.
Over to Balaji. I think it's going to talk on chiral thiourea ligands for asymmetric catalysis. Over to Balaji. Thank you.
Yeah. Thank you. Right. Yeah. Good morning to you all, and it's a pleasure to be here. I was told that I have to give a lecture, and but I wasn't told that I have to give right after to Prof. Chakravarti. It was very challenging and honor, and it's a pleasure as well. After listening to a very illustrative lecture, with the time frame starting even before of my birth. Okay, let me share my screen. I hope I can do this right. Okay. First of all, good morning, sir. Wish you a very happy birthday, many more happy returns of the day. It's nice to be here in this morning and present the work. It's a very special day. It happens to be the 75th birthday of sir, who happens to be the CNS of our scientific thought processing. Since I wasn't even born at the time the Professor Chakravarti gave a lecture in the beginning of the Kanpur. So I would rather prefer for this afternoon, like to share a very short story, how we found that thioureas could be a potential ligands for the asymmetric copper catalyst and its application in the addition of the fluoronitriles to aldehydes and imines. Is my slide visible?
Yes.
Yeah, okay, yeah, fine, thanks. Okay, and then, okay. I'm sorry, yeah. As we know that quaternary fluorinated stereogenic centers are extremely important in the pharmaceutical industry. However, access to them are very limited due to the challenge in synthesizing them when compared to the other fluororganic molecules. Of the available method, most of them rely on the electrophilic fluorination to the electron-rich carbon system or the olefins. On the other hand, very interesting convergent approach in which we could add the fluoropronucleophiles to an electrophile, where we could have a diversity, quick access to diversity, has not been realized much due to the inherent challenges associated with it. Almost a decade ago, Wohler Group has shown that the fluoronitrosulfonyl system could be added to the conjugated system, yielding a quaternary fluorostereogenic center using the quinine catalyst. Very recently, with the very interesting design of the Bronsted base developed by Johnson Group, they could show that the fluoronitro system could be added to imines, yielding the beta fluoroamines with the quaternary fluorostereogenic center with the excellent enantiomer selectivity. And also, TOS group could show that alpha fluoro special cycloketone could be added to imines, yielding the beta fluoroamines. Prof.SCN group, when I joined, even before I joined, they have very long interest in the nitrile activation in the catalytic asymmetric synthesis. And what we thought is that if you could successfully add the fluoronitriles to the imine in the asymmetric copper catalysis, we'll be able to get a structural motif having the beta fluoramines, where the fluorine is attached to the crafton stereogenic center, and having the nitrile, which we could use for the further multiple functionalization. And accordingly, we tried to add the prototype fluonitrile to imines using the benzalate derived imine and the fluonitriles. And what we found was that in most of the ligand system, the reaction worked well, and we could get the good yields as well. However, the diastereomere selectivity was not still satisfactory. Even we could get the up to 82. And the DAOP system, the case was more interesting, where we could get the good diastereomere selectivity and not the enantiomer selectivity. With the typical standard way, we in fact decreased the temperature and we did various things, various modifications. However, realizing good enantiomer and diastereomere selectivity at the same time remained extremely challenging. We couldn't meet that. So we revised our strategy with our experience in the cooperative multi-catalyst activation. We thought that if you could differentiate the phases of the imine and then we add the nucleophile to that, we can get the better selectivity. Thereby, we can solve the problem of the diastereomere selectivity. Accordingly, we introduced thiourea to the working catalyst system. What we found was that the well-known or the standard hydrogen bond donor, hydrogen bond donor thiourea did not facilitate the reaction. Whereas in the presence of alkyl thiourea, we could get the product formation with a little bit increase in the diastereomere selectivity. Surprisingly, diisopropyl thiourea gave the product with the good enantiomer diastereomere selectivity, although with the lesser yield. This suggested us that something else is going on in the flask than the hydrogen bond activation. So we undertook the systematic study of the thioureas, and what we found was that in the case of alkyl thiourea, a simple substitution can make a great difference. For example, from yield close to traces to the yield of 70 with the good enantiomer diastereomere selectivity could be observed with the introduction of the thiourea, where its modification is just nothing but the simple alkylation. And the case is not the same when we proceed further to the tetra substituted thiourea. That suggests that this tri substituted thiourea is more suitable. And then for the achieving the good enantiomer diastereomere selectivity, we did the further optimization studies, and we found that isopropyl thiourea happened to be the best candidate, and where we got the excellent enantiomer diastereomere, all the selectivities. Actually, when we say the thiourea, the first thing comes to our mind is that they are very good hydrogen bond donors. This is after because of the breakthrough work by the Jacobson. And interestingly, in fact, the Jacobson group, when the paper, if you could see the paper that's published by the Jacobson and Sigman, they really wanted to do the thiourea as a ligand, and however, they found thiourea as the hydrogen bond donor. Thereafter, the new chemistry was born. And we suppose that in our case, from the 10, we observed that this might be acting as a ligand. And to confirm our hypothesis, we did further studies. First thing is we observed the phosphorus NMR, as we could see that when we introduced the metal to the phosphorus, we could see the shift. On introduction of the thiourea to the system, we could see the further shift, indicating that thiourea is acting as a ligand here. And that was not the case when the metal was introduced with the imine or the nitrile. That's suggesting that thiourea is a preferable ligand. And once again, when you introduce thiourea to the mixture containing imine or nitrile, you see again the shift. This is proof that the thiourea here is acting as a ligand on the reaction rate. And what we found was that upon introducing equivalence of the thiourea to the copper system, we could see the deep decrease in the rate of the reaction. This is typical of the reactivity of the Lewis acid and then the Lewis base acting as a ligand, and then thereby decreasing the rate of the reaction. And after the one equivalence of the metal and thiourea, we could see the plateau that is suggesting the preferably the mono coordination. And the rates were in between that when we have the half of that, suggesting the multiple species presence. To understand the reactions still further, to get some more evidences, we conducted the initial rate kinetics. And what we found was the second order with respect to catalyst that's suggesting the dinucleate pathway, and then the imine coordination that is well with the speculation. And very interestingly, we observed the saturation kinetics with respect to imine. Yeah, yes. Saturation kinetics with respect to imine, suggesting the stronger binding between the imine and the metal with a very small Michaelis Menten constant. And since we observed the binuclear pathway, clues for the binuclear pathway and second order, so since we're also working on the chiral system, we confirmed we studied the nonlinear effect by seeing the effect of the enantiomer selectivity of the product using on comparing the enantiomer selectivity of the ligand. Indeed, we observed the nonlinear effect with a small decrease in the enantiomer selectivity when compared to the expected linear level, and this is fitting well with the Kagan's binuclear system. And with these evidences, we propose that thiourea binds to copper and makes the system no longer C2 symmetric and makes only one site available for coordination to these nitrile coordinates. And further it gets activated, that's good enough to be deprotonated by the Bronsted base. And there you see then the ketimine being formed, and the imine coordinated with the copper reacts with this one, where you can see in the activated state, you have two copper nucleus, one attached with the imine, one with the nitrile reacts. And after the carbon-carbon bond formation, one of the copper is released by the coordination of imine to it, releasing the product amide, and that is further released. The product is released by the deprotonation, and the Bronsted base cycle goes on and releasing the catalytic active species into the catalytic cycle. And the reaction was found to work with various imines, for example, substituted aromatic imines. Interestingly, with the aliphatic imines as well, we could get the interesting enantiomer diastereomere selectivities, conjugated system, and heteroaromatic attached system. In all the cases, the reaction was found to be broadly working. And the reaction is not just limited to the phenylfluonitrile, that could be extended to other substituted nitriles as well. Thus, obtained product could be readily transformed into highly valuable amino acids and amides, indicating the power of this method. And next, we move on to the addition of the fluonitriles to the carbonyl. It may seem so obvious that, come on, if it could work with the imine, it should be able to work with the aldehyde as well. And that's the case for the racemic reaction, where we'll see that it's not the same when it comes to the catalytic asymmetric synthesis. And it's not simple as well. As you can see that, in fact, for Shibashaki group, they have been trying to add the alkyl nitrile to the aldehydes in a selective manner. And that's a problem that's close to be 2 decades. And they could get some interesting results that they have shown that using the tuned BiPEP, they could obtain the product up to 77% E. And with the substituted nitrile, they could add it to the aldehyde with the good selectivities using the ketone. And recently, with the rhodium NHC system, they could add acetonitrile to aldehydes with the moderate enantiomer selectivity. And interesting to note that 2 former members of a group were involved in this program as well. On the addition of the fluoronucleophiles to aldehyde, constructing the quaternary fluorostereogenic center, you could see that it's extremely challenging. Only few methods are available, and that too with the special carbonyl system. And one of the cases where you need to have the D-trifluoroacetylation with a very poor atom economy. And recently, Cross group also shown that this could be accomplished. However, this is limitation is a special fluoro system. Since we could be able to add the fluoronitrate to aldehyde imines, so we next check the feasibility on the addition to the aldehyde. And what we found was that in this case as well, all the cases the reaction works well. However, the selectivity is very poor. And from our experience and then the experiments we conducted, we suppose that this could be because of the retroaldol reaction. So since we have the thiourea as an handle, we introduced that one. And we could see that in the absence of thiourea, in fact, although the reaction works perfectly fine, where it does great damage to the stereoselectivity, and we see a very poor stereoselectivity. Once again, you just introduce a thiourea to it, you are already in the good selectivity, although in a very good selectivity for the NHO, but whereas moderate diastereoselectivity, the case becomes more interesting in the case of the aliphatic aldehydes, where you could see that in the absence of thiourea, almost only the traces of the product were formed. Once you introduce thiourea, in addition to the stereoselectivity, we could see the increase in the yield of this reaction. In the case of the aldehyde reaction, what we found was like more interesting than the imines. In this case, upon introducing the thiourea, the reaction rate increases, unlike the case that happened for the imine. The reason which I'll show you later. And in the initial rates as well, you can see that when you have the thiourea attached to copper species, you see the shoot up of the reaction, whereas when you don't have the thiourea, it's a simple copper ligand system, you don't see any progress in the reaction. And the reaction works well, pretty well with the various alkyl aldehydes, which are extremely challenging due to their feasibility of the isomerization and self-oral reaction. And we could see in most of the cases, the reaction works well, and we could get the product in good yields, good NaCO, decent NaCO and decent diastereomers selectivity, various alkyls, cyclic alkyl attached, and then the functionalized systems such as the phthalamides and then nitriles, where you could selectively deprotonate the nitriles, and this could work well with the conjugated systems as well, where with the lesser selectivity nonetheless, when we go to the aromatic system, the reaction works well, especially in the electron donating aromatic system, the reaction gives the better selectivity. In this case as well, it's not just limited to the RL substitute. RIL substituted nitrile, and this could further be extended to the very substituted nitriles. Okay, and that's upend product could be transformed into various functional group, amides, amines, and then the aldehydes, and that gives the access to the various chirally important molecule. And okay, to put it short, when you don't have the thiourea, you could see the retro reaction, which is not desirable for the chiral reaction. Once you introduce thiourea, you actually stop the retro reaction. And especially in the case of alkyl thioureas, you see the rate increase, basically due to the product release. And in summary, we could find that thiourea could act as a very good ligand for the ligands for the copper catalyst. Thereby, we could add successfully the fluoronitriles to imines, the access to the quaternary fluorostereogenic center, having the beta fluoroimines. And also, we could also shown that this could be added to aldehyde, which are extremely challenging. And thereby, you could have the beta fluoro alcohol containing the quaternary fluorostereogenic center, where you could go from the level of the no reaction to the 20 mol%. With the introduction of 20 mol%, you can get the yields and the initial diastereomers selectivity very well. Since I presented this work, mostly the work that I presented this time is done mostly in the Professor Bishaki group as a postdoctoral fellow. I would like to take this opportunity to thank Professor Bishaki for providing me the opportunity to work in his group. Dr. Noah Gomagai, Professor Bishaki research group. And currently I'm working as a postdoctoral fellow in the Professor List group. I would like to thank the WP and ICRED for the support, Professor List for providing me a chance, and WP ICRED. Okay, before I close, and as we have seen that to have the reactants well, and then to get the product in a very good selectivity of the desirable reaction, you need to have a good catalyst with the proper matching, which is nothing but the fruitful collision. In an analogy, actually, not all Narendranath becomes Vivekananda, and the Narendranath who have the quest for research and can't become even Vivekananda. The Narendranath who have the quest for the answers, and then who are fortunate enough to have a mentor like Ramakrishna Paramahamsa, are the few who become the Vivekananda in such way that we are a bunch of the extremely fortunate graduate students in this country who had a fortune to work with Sir. And I personally feel proud, and then thank you very much, Sir, for providing opportunity to work with you. And thanks for the organizers for giving me this chance. And finally, thank you all for your kind attention. Thank you.
Thank you, Balaji, for this inspiring talk, for taking us through your research journey on chiral catalysis. I think we will have some time for one or two quick questions.
Shall I ask a question, Gopi?
Sure.
Yeah, thank you. Balaji, it's a very nice presentation.
Thank you.
Before that, sir, many more happy returns of the day. For a nice time I'm able to participate here. Balaji, the question is that
yes.
When you use this mono hydrogen added thiourea, what's the role of hydrogen Is there any activation through hydrogen bonding, single hydrogen bonding?
It's basically you need to have a two hydrogen chelation. It could be happening. I feel we presumably think that it's symmetry is the matter basically. When you have the already chiral pocket, when you have the let's say the tetra substituted one, you already have the good selectivity. Selectivity not so great, but still you have 5.8 into 1. We assume that it's basically should be happening because of the symmetry largely, or let's say to put it sterics, not through another force like hydrogen bonding. Because when you see the structure, it's difficult to have a hydrogen bond activation and Lewis acid activation together.
Okay.
Because the ring size will not allow you to make that. That won't be feasible.
Hydrogen as a small size makes the difference rather than hydrogen as a hydrogen bond donor.
Yeah, we already for the activation parameters we already have Lewis acid. That is not working on the. Actually, if that is the case, when you have the hydrogen bonding, you should have the enhancement in the rate, right? Basically, that is not the case happening. You see the depletion in the rate. That basically is saying it's ligand.
Okay. Okay. Thank you.
And it, yeah.
Okay. Can I ask one question?
Is that okay?
Yeah, Datta, go ahead.
Yeah. So, Dr. Balaji, excellent lecture.
Thank you. Thank you. Thank you.
Actually, I was wondering if you use the chiral thiourea catalyst, then
Yes.
you can avoid the sec-phos and just one ligand would be enough. Have you tried that?
No, we haven't tried that, but yeah, we haven't tried it. But my guess is that it won't be the same. Basically, you need the phosphorus ligands, and in fact, it is very specific. The pocket is very specific. For example, DTPM sec-phos. And even if you go to DTPM biprep, you have selectivities. I'm not speaking about the reactivity. Selectivity is extremely different. I feel this has to do with the proper formation of the chiral pocket.
Okay.
Gopi?
Gopi, oh, nothing. Yes. Yeah.
Hi, Nazir.
Hi.
Yeah, I think Professor T.K. Chakravarti wants to ask the question, maybe then followed by Nazir.
Yeah, but we have very limited time, so please keep the question and answer session.
First of all, happy birthday to sir. Sorry, I joined a little late. There was some issue with my computer. But anyway, Balaji, I saw your catalysis thiourea, and I see the temperature is minus 80.
Yeah.
And minus 80 is a too less temperature for any catalysis. So what do you think that, are you working on making temperature close to ambient or a minus 80 is too less. So what kind of changes you are looking for to make it better?
Yeah, actually, I didn't show you. What we wanted to have is, we didn't want to have minus 80. We wanted to have it at least decently minus 40. It's okay, decent minus 40. Although not the zero level, because it's very reactive system. Once it have once the nitrile gets into the metal, it becomes extremely reactive. So I didn't show you, we almost did more than 100 of new thioureas where we could do low temperature, where it's like catalyst activation. I would say that now we are making a more of a thermo control as well as a parameter. We wanted to have more of a catalyst control alone. For example, it would be very desirable to have the room temperature where your catalyst gives the 99% E, 99% quantitative yield, and then DR more than 20 to 1. But still, it's a challenge. This is the first step that we could cross.
Yeah, Professor Chakrabarti wanted to ask a question.
Yeah, just one quick question. Balaji, very nice presentation. And
thank you, sir.
I have one question, because I gathered that, without the fluorine, your enantiomer selectivity is not good. Yeah, you need a fluorine there.
In this
fluoronitrile, fluoronitrile, right?
Yes, sir. Yes, sir.
Yeah. So did you think of any way to remove the fluorine after the reaction? Suppose by through epoxidation or through acidination, and stereoselectively you can again open it up, like with a hydride, to make, for example, like a beta amino acid. Beta amino acids are very important,
Yes, sir. Yeah, that is the way we justified the introduction as well. Of course, we justified that there's a fluoroquaternary stereogenic center, synthon. That's what we meant. That's an interesting point. We never thought about removing the fluoro. We wanted to have, this is an important
remove. After getting the product, if you have to remove the fluorine, how would you do that? Like it is possible. Like you can have an aziridine, or you can have an epoxide. and then again open the epoxide in two-step process kind of thing, you know.
Okay. We never thought about it. We thought
If somebody does not want, you know, like someone doesn't want the fluorine, then what do? You know, your method is good to get a good enantioselectivity,
Yes.
but then at the end, I don't need a fluorine there.
Yeah, actually, from the Shibashaki group, 2019, they published work, an organic letter that you can see. That is after this thiourea, we found that we don't need the two coordination sites available. And then we designed the pincer complex, that we have only one coordination site. We can have better control. And that way, they could add it to the imine, but still they're working on...
Without fluorine, you get only 68% EE, right? You know, without the fluorine in the alpha position of the nitrile. Some of the other work you have shown, you know, Shivasaki's work and all, they are getting low.
Yes, sir. Actually, that is still working. They're going on. They got the 90% EE that's going on now with the simple aliphatic, with the new catalyst, with the pincer type catalyst. They could come up with that one. That's going on. I will soon hope, fortunately, hopefully they'll be able to publish it. So.
Very good. Thank you.
Thank you, sir.
So due to time crunch, we'll stop the questions here. Let us all thank Balaji for his talk. And I hope there are more questions he can address a bit later. Thank you all, and over to the organizers.
Thank you very much, Gopi. With the loads of chemistry in the morning itself, we'll have some fun now. So we are going to play a video, very special. So we could collect some very memorable moments from Sir. Many of us have wished him, and then many of our wishes have been also trimmed because of the time crunch again. But I will make sure me and RGP will send the entire wish. Somebody has probably sent a 10 minutes video. So all those videos will be shared directly to Sir. But now we have compressed everything and then wanted to just play 12 minutes video that we made it for Sir. Okay, over to Raja. So Raja, volume. This is for you, Sir, from all of us.
Volume, Raja?
Yeah, volume, Raja. There has to be a volume.
No, computer sound has to be shared.
It's fine. It's there now.
No. I can't.
And Bluetooth sound over.
For you to come visit Austin. Hi, Papa. Happy 75th birthday. Yes, sir. Happy returns of the day. Have a great day.
Your Fuso Bluetooth device is ready to pair. Bluetooth mode. Connected.
Hi, Abu. I'm reminiscing our 45 years of togetherness. You brought me out of Madras Agrahara and have flowed me all around the world. We have been together in happiness, joy, sadness, pain, everything. Even in this COVID time, we have been blessed with our lovely granddaughter, Kinara. It's absolutely the time to celebrate your life with our family of students, and with our extended family of friends. 75 years, oh my gosh. You had so many accomplishments in these wonderful years, and you've done it all with so much grace. As you know, we named our daughter Kinara Chandra Janadi. And we gave her your name as her middle name, and that was on purpose. Because we really hope that when she grows up, she has your kind of passion. feeling of human bodies, all of your Chanda.
ஒரு மினிட் டிலே இருக்கு கண்டிப்பா.
ಶುಭೋದಯ. ಮನಸ್ಸನ್ನು ಶುದ್ಧಿ ಮಾಡುವ ಮೌನದ ಹಾಗೆ, ಆತ್ಮವನ್ನು ಶುದ್ಧಿ ಮಾಡುವ ಪ್ರಾರ್ಥನೆಯ ಹಾಗೆ ಸರ್ ತಮ್ಮ ಶಿಷ್ಯವರ್ಗದ ಜ್ಞಾನ ಶುದ್ಧಿಗಾಗಿ ನಮಗೆಲ್ಲ ಸನ್ಮಾರ್ಗಗಳು ನೀವು ನೂರಾರು ಕಾಲ ಸುಖವಾಗಿ ಬಾಳಬೇಕು.
Dear sir, namaste. I wishing you many happy returns of the day. May Ishvara bless you with long, healthy and happy life. Have a nice day.
Hello, sir. Wish you many more happy returns of this day. Thank you for being such a wonderful supervisor, sir, and thank you for all the support, sir. Because of you, we are not here. See you soon, sir. Hello, sir.
Hello from Kharagpur.
Wish you a very happy 75th birthday and a wonderful year ahead.
And many congratulations for being Pradhan Party.
Very happy birthday.
Dear sir, wish you a very happy birthday. Wish you many happy returns of the day.
Happy birthday, sir.
Happy birthday, sir. Wish you many happy returns of the day.
అందరికీ నమస్కారం. ప్రతిరోజు జన్మదిన జరుపుకుంటున్న ప్రొఫెసర్ శ్రీనివాసం చంద్రశేఖర్ సార్కి నా హృదయపూర్వక శుభాకాంక్షలు. I want to say to all of you that I learned a lot from Sir and Research family, especially the Macha gang. And I have joined as a last graduate student in 2008, and those are the most memorable days in my life.
May God shower you with all the choicest blessings, and very happy to hear the recent promotion on becoming a grandfather. Best regards from all of us.
Yes, sir, I appreciate you not only being a wonderful professor, but also encouraging me during difficult times.
Thank you, madam, for your motherly affection. Happy birthday, sir. And I thank you for extending yourself beyond just professional words.
Wishing you a very, very happy birthday, sir. May God bless you with long, healthy, happy, and prosperous life along with Jayanti ma'am and time.
I'm happy to send my wishes on your 75th birthday. It's one of those who truly inspired me.
Hello, Professor. Wishing you a very, very happy birthday to you. And thank you for being a part of our happiness all along. And we are very fortunate for that. And once again, myself, Radhika, my son Samarth, and daughter Shivani, wishing you a very, very happy birthday to you.
On a personal note, I'm really grateful to CN for all your mentorship and support. And in fact, today, whatever I am at this point of time, I think you are largely responsible for it. Thank you, Professor and I wish you and your family a very happy, memorable birthday celebration.
Sir, ನಿಮಗೆ ನನ್ನ ಮನದಾಳದಿಂದ ಹುಟ್ಟುಹಬ್ಬದ ಹಾರ್ದಿಕ ಶುಭಾಶಯಗಳು. Wish you many more happy returns of the day. Happy 75.
Wish you many, many happy returns of the day.
Happy birthday, sir.
Happy birthday, sir.
ఇలాంటి రోజు వెళ్ళి మరెన్నో జరుపుకోవాలని మనసారా ఆకాంక్షిస్తూ వెంకటేశ్వర.
Happy birthday, sir.
Happy birthday, sir. Wishing you many, many more to come along with Jayanti.
And wish we all celebrate your 100th birthday.
Many more happy returns of the day, sir.
wishing you a very, very happy birthday.
Happy birthday. Happy platinum birthday. Professori.
Thank you, Raja, for playing it. I think there was some glitch, so it was delayed, but this video will be shared with all of you. When you probably watch it on your own computer, it probably plays much faster than we checked all of this, but even then it was having some trouble. So I hope, sir, you enjoyed all the memories. So over to RGB.
Thank you once again, Shiva and everyone. And it's a joyous moment, as I said. We cannot celebrate in just in 2 hours, as we discussed earlier. So we have planned for the events for the year to come. And this COVID has forced us to plan in a different way. Otherwise, we could have just planned maybe a 1 day or 2 day conference. That usually happens. But I think, maybe blessing disguise, we will celebrate for the whole year to come. So I request now, there are many people here, the distinguished scientists who are here, they know SCN from quite long time. So we request some people to wish him, say a few words. And it's our pleasure and honor that we have distinguished scientists like V.K. Singh, Dr. Gopalan, and many are here. So to begin with, I request Professor V.K. Singh, IIT Kanpur, to share a few words and say a few things. Welcome you, sir. So you seems to be mute, sir. Yeah.
I was very happy to receive email from Supriya, and at the outset, I would like to wish Professor Chandrasekaran a happy birthday. It's a very special day because Professor Chandrasekaran and Jayanti, they just became grandparents, and I'm happy to see Aarti and Ramya. They are here, and very soon they will be joining them. You all feel that he had been very nice to all of you, and that is why he's a great human being. That's not correct. It's normally what I believe. Person should be good to everything. And Professor Chandrasekaran has one quality. He has a positive mindset for everything. He had been nice to not only to students, but large number of people, colleagues and system. He's an outstanding science administrator, high level of professional ethics. I have learned a lot from him, especially by attending meetings. You get to learn more from him. There are people who attend meeting without any preparation. When you see Professor Chandrasekaran in a meeting, he has done the groundwork, homework, and everything goes so smoothly. I always believe that people should work for system. And I have not seen many people in the country who work for system. People who don't work for system, I consider them selfish people because they only work for themselves. And if some time left, it comes for family. But he is a different human being. I tell you because he spends more time on the system for work. And that is the reason he is able to care family much more than many of us. I have not met, I have met once or twice, but not many more times, Ramya and Aarti, but I know more about them. And the other part which I like to mention Aarti because Jayanti, I knew her, but had not known her that much. I got to know more when they were visiting ISER Bhopal. Professor Chandrasekaran was J.C. Bose chair professor for a month. She's a wonderful person, and maybe all the niceties Professor Chandrasekaran has got, I wonder whether because of Jayanti or Jayanti imbibed from him. But I tell you, I love them so much that whenever me and Anjali with them, we have feel good factor. We treat them like a family. So I wish him a happy and long life, and I'm sure they will have wonderful life with Aarti and their young kid. I just saw the photograph. Congratulations. Thank you.
Thank you, Professor Vinod Singh, for the kind words, and thanks for being part of this function. I kindly request Dr. Gopalan. I think he's here. Dr. Gopalan has been a long standing friend of Professor S. Chandrasekharan. Dr. Gopalan, can you hear me? I could see just Dr. Gopalan. Just
Have to mute, huh? Yes, he is here.
okay.
And if you can, just yeah, we can see you.
Yeah, Dr. Gopalan is there.
I don't know what I should do in this because I'm not able to get this.
No, no, you keep speaking. We can see you. You keep speaking and wish him, and we can see you clearly.
One thing I first of all I wish to congratulate Dr. Chandrasekharan that he has produced so many very good students, and this is a milestone that 75 years is a milestone, and he has enjoyed every bit of it. And I know him since his days, since my days in second BSc in 1967. Because after finishing his MSc, he was a demonstrator in Vivekananda College, and he used to teach us in the laboratory of Vivekananda College. Since that time, he is known to me very well, and he has come from a very humble background, and he has risen to this level. And among the Professor Swaminathan students, he is the best student who has got all the academic awards, academic accolades, and he has come up very nicely, and all his publications, each and every one is a gem of a publication in different journals, and he has worked in premier institutions. And of all the things, he has been my teacher, mentor, a well-wisher, a good friend, and he continues to be like that. And he is a person very amicable to everything, and his diplomacy and also his intelligence, and I admire him for all his work that he has done and produced very nice people, very good people who have been in high positions in either academia or industry. And I consider myself very fortunate that I have been, he is known to me for such a long time. And I still continue to get in touch with him, and I wish him all the best. And God should bless him with a robust health, longevity, and his continued happiness with his family. And I know the family also very well, even his brother and other people also I know very well. And he is a very pleasant person to move with, and he has never done harm to anybody. On the flip side, he gets very angry very fast, and if he gets angry, then people should see how he is. I don't know whether anybody has seen him getting angry. And people used to say that Mookan will get angry. Be careful, they will say. And I really admire the way he has come up, and I wish him all the best in his future and more accolades. And God should be merciful to give him long life with good health.
Thank you, Dr. Gopalan, for your kind words. Thanks for your time. I request, I think Professor Bhaskaran is there here from IIT Madras to say a few words, because I think Professor Bhaskaran, it must be a kind of really linchpin, I guess, one of the very few people who worked in IIT Kanpur, and maybe a few months or a year he spent in IISc, I guess. So, Professor Bhaskaran, thanks for coming here on Zoom.
Indeed, a great pleasure for me to join this, like a very, auspicious occasion. And first of all, I would like to wish Professor Chandrasekhar for his happy birthday and many more happy returns of the day. And actually, I vividly remember when I moved to Kanpur, actually means 1984, I think December last week, something like that. It was on Sunday. And when I went to his, I decided to know immediately I wanted to meet him. I never met him before. So I went to his house, and first I met Jayanti. She was coming out, like opened the door and with, a small baby in her, hand. And that was Aarti actually. Very small, maybe less than 6 months old, something like that. And now herself is having a baby, and it's really indeed a great moment for Jayanti as well as for Sir become this grandparents. Actually, it's really a remarkable one. And actually, when I joined, people always say that, those days, facilities were not there, something. But SCN, I also say that SC, that time in IIT Convo is known as SC 2-star gender. After moving to IIT Bangalore, it became SCN, that's 3-star. And 1990 it became 4-star general, something like that. This is what I feel that, I've seen is, trajectory, everything. And I was part of the thing during that, starting from assistant professor to that Bhatnagar award winner and all those things. It happened during my tenure as a graduate student in his group. And his lab-wise, a very vibrant group, and more than 15 students were working. Actually, everyone longed to work with him, as even the MSc student, 4 or 5 students used to work. And always difficult to get a place to find, even the stirrer in the lab. Actually, means the people early morning when I used to go, they always put the resort, Rajendra Rathur, he's no more. And he used to be a hardworking guy, always used to be there in the lab. And always, we used to fight, getting the stirrer is always a problem. He used to resort many stirrers, because those days he was working on very hot area like a CTAP, I don't know how many of you remember that. And even Vidya Bhushan, she was working on the same thing. And, the lab, we had everything, for SCN's group, even the independent IR we had, and the HPLC, GC, TROSCAN, everything we had it, a very high-tech lab. And I was really very fortunate to get into the lab. And today, Professor Tushar talked about chromium. I was, after his thing, I continued to work on that. We try to look at the mechanistic aspect of those things and so on. It's really if I look back and something that my exposure and all those things I see, and I can conclude that SCN gave a free hand to everyone. He used to suggest a thing, but you allow people to think, come up with the ideas. He encouraged that kind of, that is a really good thing. The process, we could develop our own thing. It really shaped our career and so on. And in my personal thing, if I see as my career, when I started, after coming to IIT Madras, each and every stage, directly or indirectly was involved. It helped me. I don't have to ask him, okay, what to do next, something. He was voluntarily telling me what to do next, something. It was really I cannot forget all his support and help throughout my career and something. And I think this is, as you mentioned, Sivapriya, as well as you mentioned, that is going to be a long, celebration. I think maybe by next year, middle of next year, I am sure that and I look forward to have get together in person. Okay, somebody's telling something. What happened? Are you able to hear me?
Yeah, we can hear you. We can hear you. I think somebody's iPhone has.
Okay, fine. So I look forward to have some kind of get together, maybe middle of next year, and in person. We should celebrate this, very, auspicious occasion. I feel that I once again, wish Professor Chandrasekharan, for his healthy and joyful, year ahead, and we look forward to meet you in person. That's what I want to say.
Thank you, Professor Bhaskaran. I think Professor Uday Maitra, good morning. Professor Uday Maitra has been again, I think he was there in IIT Kanpur, and then he's been moving with SCN and is in IAC Organic Chemistry Department, and we have seen him over the years, and he's been a teacher for some of us as well. Welcome you, Professor Uday Maitra, and I just over to you.
Thank you, RGB and Shivapriya, for this opportunity. I have slightly difficult circumstances because the power has gone off about half an hour back. So I'm on borrowed power from multiple sources. So thank you very much. And SCN, many, many happy returns of the day. Now power has just come back.
That's glowing.
Good timing. Have a wonderful time, good health, and many, many years of active interaction with us, which is something that we really appreciated. You know, my association with SCN dates back to 4+ decades. I did my 2-year MSc from IIT Kanpur, joined in 1979. But my formal association with SCN was only 1980, first semester, which was the 3rd semester when SCN taught this Chem 511, physical organic chemistry. And also he took some special lectures in Professor P.T. Narasimhan's physical methods in structural elucidation.
Yeah, I think that is seems to be. I think we lost the connection of Professor Maitra.
Power went off, maybe.
Maybe, yeah, power went off. Fluctuation is there.
No, I think he's coming back, RJB.
Really bad, you know. Power goes off. And,
yeah, there are pros and cons of this.
We can wait for a couple of seconds, RJB.
Maybe, yeah, maybe. It looks like because I think you'll have a connection, because I think it would take at least a minute to come back, because yeah, I think he must be getting connected. Yeah, he's back again. He's back again. Continues.
I lost connection for a few seconds.
No, we paused the time.
Oh, okay. So do you want me to stop?
Yeah, please. We had paused the time. You can continue again, please.
Okay. All right. Yeah. So you know, I've received many professional and also personal interaction. I had many interactions with him, which I really appreciate. And I don't want to take anybody else's time, you know, by speaking about many of these fond memories. But I do wish to share a PowerPoint with some old photos, and that will be my contribution to this event. Can I share my screen?
Please, please.
All right. Okay. So there are some pictures with, and it's really wonderful that Aarti and Ramya are also around, and it was nice to see the little one. So let me, let me start from here. Okay, I hope you can all see this.
Yes.
I think in the video, this picture was flashed for a short time. This was taken in my old Click 3 camera in 1981 after we finished our project presentations. So you can see the faculty members there, and 5 was the size of our class at that time. Muhammad Ishaq, Deepankar Chaudhary, Ashish Saha, and Professor Arun Ghosh. I will show a nicer picture. And this is yours truly. Here's a picture from a picnic we did in 1990 from the Department of Organic Chemistry. I don't think SCN went with us, but you can see Jayantiji right here, and some of the other members of SCN group and my couple of students. Bhaskaran is here, Chidambaram, Preeti, and Jagataran. And there were a couple of summer students at that time in the department, in SCN's lab. Here's a picture of SCN's group in 1990, and I'm sure that you can recognize most of them. I'll jump to 2000. This is a Jaipur NOST, and we had this meeting in the Ashok Hotel. And here is SCN's picture. Didn't come out very well, but I thought I should share this with you. These were some personal pictures taken in the early 2000s. SCN, Jayantiji, and Professor Satyamurthy's daughter Aruna, they came at that time. She was doing a summer project with Professor Balram, I believe. Then this was our MitoCore team in 2002. Again, some of you would have seen or known these people who worked in different places. And here's a picture from Arun's, Professor Arun Ghosh's visit in 2003. Aarti is here, Imadul Islam is here, And of course, you can see Jayanti there. Then the next one is, this was supposed to be a surprise party, and many people, including Shiva Priya and his students, and we sort of conspired to have a surprise. Of course, I think this was not a surprise to him, but here is I am offering a bottle of champagne to SCN when he came through the door. And again, you can see Aarti here, Shiva Priya, Rajeshwari, and many others you would recognize. I think this is Ganesh, right? Gopinath, and others, Nilesh, and so on. And, last year we had SCN's birthday celebration 4 days ahead of time. You can see him cutting this cake. This was in Hobart. And for those of you who are geographically challenged, here is where Hobart is located. So this was really an unusual place to have a birthday celebration, but we managed to do it. We chose to go from Melbourne to Tasmania rather than to Sydney, and SCN was very enthusiastically agreed to my suggestion at that time. And we had a great time in Tasmania, including a somewhat turbulent boat ride. And so I would like to end my brief presentation here. SCN, my family and I really enjoyed interaction with you and association with you and Jayanti, and of course, we always enjoy Jayanti's, incomparable hospitality whenever we went to their house. And I again would like to wish you and Jayanti good health and many more years of association with us and with the greater SCN family. Thank you very much. But before I close, I would like to flash one slide to say that I can't wait for the grand celebration 5 years from now. And I hope that will be a real celebration. Thank you all very much.
Thank you. Thank you, Professor Maitra, for sharing the pics and rekindling the old memories. Kindly, I think Professor Farooq Khan is there. Professor Farooq Khan is here. Professor Farooq?
Yes,
yeah, thank you for joining from US.
Thank you for inviting me. I want to thank the organizers and Professor SCN, or Chandra, as we used to call you. Many happy returns. It's good to see all of you. I have a couple of brief anecdotes. I was a part of the Professor Chandrasekharan's lab as an integrated MSc student. And I vividly remember the farewell party that we had for Tusharda. I joined the group around the time Tusharda finished his PhD in 1984. And I overlapped with him maybe just a couple of weeks. It was good to see Bhaskaran. It was good to see Uday. Uday and I overlapped at Columbia for about a semester. So it's good to see so many familiar faces. A few things about Professor. I was struggling in his course, Chem 402, and he was kind enough to take me aside and give me a few words of encouragement. And later on, I was a part of his research group. I am now a physical chemist. I teach quantum mechanics and thermodynamics. But I remember my Grignard reactions, which were a struggle because it was so humid over there. Entrainment, doing columns. And so if I can remember all of that about 36 years later, I have to say that he had a wonderful atmosphere in his group, which was conducive to learning. And although his group was very large, some of you all mentioned the group size, 10 to 15 students, he took great pains in spending time with each of us, and we learned a great deal from him. I have been teaching at the University of West Georgia now for 26 years. And I must say that I emulate or try to emulate some of the features that he showed in the classroom and his research lab as well. We had the sad occasion to meet at Professor Rathod's memorial 2 years back at Marquette University. But other than that, I seem to meet him maybe once every 15 to 20 years. I do hope to join the celebration, the grand celebration 5 years from now. It's good to see you, Jayanti ji. Aarti was a baby around the time I joined the group in 1984. And it is wonderful to see that she is a parent herself. Congratulations to both of you. And I again want to wish you a very happy birthday, wish you continued success, continued good health and longevity. And happy Diwali to all of you.
Thank you, Professor Farooq. Professor Prabhu is over here. Professor Prabhu also organized, I think, 70th birthday celebration. Professor Prabhu, can you hear me? Am I audible?
I can hear you.
Yeah. Thanks, Prabhu.
Yeah, it seems like indeed a great pleasure to be part of this meeting. And we should be thankful to probably Shivapriya and RG Bhatt, who shot the first email to most of us about this event. I think, am I audible? There is a problem here. Power has gone, as Uday mentioned, half an hour power was not there and just power has arrived. Anyway, my interaction with Professor Chandrasekharan starts with the day when he joined in Science. He joined in March 1990 and Professor Maitra joined in probably June or July of 1990. I joined in the December of 1989. And in fact, we were wondering a new professor coming from IIT Kanpur to Bangalore. And most of the researchers who knew Professor SCN by that time were pretty much excited at that time. That is the time I remember that he got also his Bhatnagar, and he has given a big party in our, the faculty hall. Is it right, Uday? If you remember, the party was organized in the faculty hall, which is not given for any other occasions now. That is one of the
first and last.
I think it was the first and the last, we should remember. I remember those occasions, and that time I was not his group member. And when I have a chance to choose anybody in the department as a research guide, my first choice obviously was Professor Chandrasekharan. And in fact, indeed, that advice came for me, none other than my other colleague, Dr. Ramesha. Unfortunately, Ramesha is not there in the meeting today. He told me that if you want to join anybody, this is the group where you can learn a lot and you can blossom yourself. In fact, I took his advice seriously, and indeed, the advice is better than what he really advised. So I enjoyed my whole stay with Professor Chandrasekharan's group, and as everybody is telling that the freedom, whatever has given to us, made us what we are today. Indeed, there is one thing that I always enjoyed and continued to groom the same thing with my group students. And it is, he has nurtured our intellectual ability, not cutting down our ideas. If you listen to most of our colleagues elsewhere, most of our contemporaries when they are doing their PhD either in India or elsewhere, and there is always restriction on students to cut their ideas short. But Professor SCN never did that. Even if you go and talk to him with a stupid idea, he would never say it is stupid. And he always used to encourage you, and most of us enjoyed it. And today what we are, because of one of that quality, made us so independent and so successful as we are today. And one more thing, Professor Chandrasekharan's weakness or strength is that coffee. You call him for coffee anytime, he never says no. You would see that many times he comes to his office with Professor Maitra after his coffee, but we invite him. He would not say no, he would join us to the coffee board. Of course,
we are missing that. Now.
Coffee board, of course. Tushar, you missed the real coffee of the campus that was given by the coffee. Coffee Board of India that you never get anywhere now. Of course, you have coffee day, but that one of the coffee we always enjoyed over there. And these are all the only minor things. And as everybody was mentioning about, there is no end to tell his qualities. It looks like very artificial to keep on talking and bringing some illustrations about his qualities. But nevertheless, most of the people who interacted with him would understand whatever you say would be less than that. In fact, me, Bhaskaran, Ramesha and Sridhar Bhatt and so many of us, we have a lot of things. As Bhaskaran was telling, 8 o'clock in the morning or 7:30 in the morning, people will come and keep starting their reactions, starting the stirrers. There would be a lot of fights. There are many of our friends who work late in the night and come back at 11 o'clock, no stirrers. So his lab is always overcrowded. And one more very important thing for most of the researchers where you work would know that SCN's lab was very, very rich in chemicals. All reagents, all solvents, all catalysts, whatever you want, it was available. That is one thing. And more than that, it is not only for his group, but it is for the entire institute. I know that those days in 1980, 89 or 90, around 1991, somebody wanted to use liquid nitrogen for 2 days. It was very difficult to get it. Ours was the only lab which had the Julabo at minus 78 degrees centigrade. I think it is one of the students from Professor S.S. Krishnamurthy's lab. He conducted one of his experiments for 2 days in our lab and he was so grateful. So there are many examples. Anyway, sir, I would like to thank you personally as one of your students who groomed me very carefully and nurtured, like most of them, what we are today. We enjoyed our life and we enjoyed the chemistry with you. We enjoyed the freedom with you. And last but not the least, Jayanti ji has also taken care of us, calling us several dinners and lunches, so on and so forth. Thank you very much. And I also wish you the many happy returns of the day. And also wish your kids, Ramya and Aarti, a very good future and the best of luck for all. Thank you very much for all of you. Thank you.
Thank you, Professor Prabhu. I think Professor, as all of you said, and Professor Vinod Singh has also pointed out rightly, that there must be someone always behind someone's energy. That is, I think maybe Jayanti ma'am always acted as a kinetic energy, and Professor SCN was, I think, potential energy. I think they always go together, hand in hand. I think there may be many people, and all of us know he's a gem of a person. There are many people may want to wish him, but there's a shortage of time. However, still, maybe if someone wants to say Shiva, I think over to you. You can request, but try to keep as 2 to 3 minutes as short as possible.
We'll have some quick wishes. Actually, Professor Jayaraman wished him online, and he's driving back from his native, so he was not able to join. And same with Professor Mukesh. Probably they will come and wish you, both of them come and wish you in person. So we will just take a few more wishes from our own group. Devan, are you around?
Oh, yes.
Yes, Devan.
Yeah, 1 second. I'm just kind of reconnecting. I was.
We can hear you, Devan.
Can you hear me? It's great pleasure to see the sir and madam and the family, SCN family here. Thanks to the organizers, Siva and RGB. I don't want to take too much time, but to be short and brief. Most of the things already Prabhuji and Uday sir covered whatever I wanted to say. So I would say sir is a gem of a person. He's a good professor, good example for a mentor on more than anything else. He makes family, his group as a family. So I enjoyed that atmosphere and I enjoyed working with him, and I wish him all the best and happy birthday. Happy many more returns of the day, sir.
Thank you, Devan.
Welcome.
Yeah. Didi?
Dwairat.
Yeah, so first of all, I would like to wish sir a very happy birthday. And I would like to thank everyone, I would say my colleagues of PhD, RGB, Shiva Priya, everybody. This has been very fantastic. I enjoyed a lot of organic chemistry lectures from experts. Today it was like a lot of refreshing myself. One of the thing I would like to mention here, and it's not the first time I am mentioning, because is that got a lot of flexibility working with SCN, and this has been pointed out by others as well. Working in a team of organic chemists, probably, I don't know, I was the only person who was a little bit different, worked in a different area of heterogeneous catalysis. And that was during my PhD. It was absolutely new to me, but sir gave me a lot of freedom to think. to explore in areas of solid supported catalysis, utilize the expertise in ISC which was present. And then in the end, I was really very happy to those kind of work. And even today, now working around 15 years in industry in SABIC, in the area of polymers, some of those kind of work has really helped. Not only the work and the kind of the thinking and the kind of the encouragement to think new ideas independently. And as I think Prabhuji mentioned that he did not discourage anyone, even no idea is bad ideas. He was very open to any. Those really helped me. So I look back to those days, and of course the I would say the good environment that was there in the lab, and the freedom, the fun, the frolic while doing the work. That is really I something miss. I miss even today in this kind of very pressure environment, but that is something I will really cherish throughout my life. So I would not take more time, and I really say that this has been fantastic. I look forward to more occasions, and finally, thank you to everyone. So over to you, RGB.
Thanks, Didi. Suresh, because these are few of our people who are not able to wish sir on that video that we played. So Suresh, finally. Suresh, are you around?
Yeah. I am around, Shiva. Hi, Shiva. Yeah. Thank you, Shiva and RGB, for organizing such a nice event. So, and with that, I would like to say, very happy returns of the day to sir, and for giving such a kind of nice opportunity. It's always great pressure, and it was nice training that he has given during the PhD time, and it's a really I really enjoyed a lot to as a PhD student to work with him. So and also I would like to thank Madam for organizing many parties and providing nice food some of the time. So with that once again I would like to thank sir.
Thank you, Suresh.
Dr. Dattatreya, quick wishes. You have joined.
Yeah, sir, very happy birthday to you. And also, I would like to thank for all your support during my PhD and my entire career. As Prabhu said, you may not be knowing, but I am one of the beneficiary for a lot of chemicals from your lab that time. So thank you for all your support.
Thank you, Datta. I think many times some of our lab chemicals we need to go and search from others' lab.
Okay. Yeah. So we have almost on time.
Can I get 2 minutes?
Abhi, I'm sorry, Abhi. You already wished in that video. So okay, please go ahead, Abhi. I don't want to get video.
1 minute, please.
Only 1 minute. Sir, it's been very happy to be part of this event. Many happy returns of the day. I can only be, I can be very happy to say that we have created a lot. You have helped us to create a lot of happy memories, helped us to grow ourselves professionally and personally. I think there's lots that I can recall from what we have, the time we have spent together during the PhD days has a long impact on all of us. Thank you so much. Ma'am, we cannot forget the love that you have shown us. We have only been a part of the extended family of all of the 4 of you. So thank you so much for all that you have done for us.
Yeah, I think maybe Shiva, Ramya wants to say something very quickly.
I think Ramya Aarti also wished sir in the morning.
Okay.
So,
I think maybe or to Jayanti ma'am, maybe you want to say something.
I think Saravanan.
Yeah, I think Saravanan
will come later.
Madam Jayanti, would you like to speak for a few minutes? So the last words would be from S. Chandrasekharan.
Unmute. Sir, you have to unmute.
Can you hear me?
Yes, yes, please.
Okay. Thank you all for coming here. Joining in this function. It's been wonderful seeing many of you after a long, long time. Thank you. I don't have much to say after this because I'm too emotional to talk.
Thank you. Thank you so much. I think, before I pass it on to Shiva, I think I would like to personally thank, of course, Sir and Jayanti ma'am, we have been thanking, but I would like to thank all the delegates and especially, all the people, at last minute, they have accepted Professor Vinod Singh, Professor Tushar Chakraborty, Professor Farooq, and everyone, Professor Prabhu, Professor Bhaskaran, and spending the whole half a day. I think this is really very joyous as well as a thanking moment for us, because indeed it's an honor for us. You also graced the event. Thank you, sir. Thanks for joining us and making this event a wonderful and memorable. Thank you. Thank you so much. And over to Shiva.
No, I think we will ask Sir to speak few words, and
please,
then
please.
Sir Ramran will take over.
Okay, can you hear me now? Okay?
Yes.
All right. First of all, I would like to wish all of you a happy Diwali. And again, I must thank Shivpriya and RGB for organizing this online meeting. So I'm told that, as many of you have also mentioned, that 75 years is really like a milestone, or what we call as platinum birthday, platinum celebration. Then when Shivpriya asked me to join this meeting, she only told me only a few days ago. I must say that now that I'm practically a platinum blonde, as you can see. So although 10 years ago, my hair probably looked black, partly due to the help of chemistry, therefore it was okay. But after that, I really thought I should probably throw my true colors in a way. And that's the time I showed up as a truly platinum blonde. Therefore, I decided that I will join the festivities and be with you. It is quite nice that I could meet all of you today. It has been a very long and exciting journey for me. For somebody who was born and brought up in a nondescript village in Tamil Nadu. So during these so many years, I have had to go through various stages, agonies and ecstasies, sorrow and happiness, in equal measure, and eventually it turned out that I came out unscathed and with a reasonable amount of success. Not too bad. Never did I imagine when I was a boy growing up in a village that one day that I would be surrounded and feted by so many of my students and friends with a lot of affection and love. That is really a truly humbling experience for me. I'm overwhelmed, really speaking. I'm not able to actually say. Today, I thought, now that you asked me to speak, at least I will try to share with you some reminiscences from my academic part of the long journey that I had. As you know, and somebody as Balaji or Gopinath pointed out, I started my undergraduate degree in chemistry at Vivekananda College in Madras. That is where I got interested in organic chemistry, mainly because I was under the influence of a great teacher, Professor N. Venkat Subramanian, who taught me organic chemistry, who got me interested in organic chemistry, and also encouraged me that I should actually take up research in organic chemistry. I must thank him for the initial nudge that he gave me in doing what I'm doing today. And it is after that I went to the University of Madras, to the Department of Organic Chemistry, to work with Professor Swaminathan. He was the doyen of organic chemistry at that time, very different from other professors of that period. He was my thesis advisor and my mentor. But in my opinion, he was way ahead of his time. in terms of attitude to research, attitude to dealing with people. He taught me a lot of things during association with him. As many of you pointed out, he was one of those who allowed freedom to his students. He wanted his students to kind of evolve and become independent scientists on their own. It is that part that I picked up from him. When I thought I would start my own career, I wanted to follow Professor Swaminathan's method of doing things. That actually helped me in the wrong way. And he was also one who actually was responsible for sending me to work with Professor E.J. Corey at Harvard. I did not apply to Professor Corey. Actually, it was Professor Swaminathan. He wrote on my behalf to Professor Corey, and I got the letter of offer from Corey. And it was that extent that he had gone out of the way to help me. It is in Professor Corey's lab, I had an opportunity to interact with Professor Corey. And of course, I also had an important interaction with a large number of postdoctorals, graduate students of high quality, drawn from different parts of the world. And that interaction actually widened my horizon. It opened my eyes. It was a new experience of interacting with these people. And this is where I learned a lot of chemistry, my interaction with those people. It is that period gave me the confidence that I could actually pursue my research in organic chemistry independently. Then it all happened. I was happy that I was offered a job at IIT Kanpur. And then I came there, joined in the first week of January 1978. Dr. Tushar Chakravarti was already there as an MSc student of IIT Kanpur. And all of you know, because many of you are faculty, you are new faculty who have been there for a number of years now, all of you know the career of an academic faculty is to a large extent decided by the first batch of students that you have. If you happen to have a good batch of students in the first earlier years, you have made it. If for some reason, unfortunate reason, that you have people who are not as good, then of course you will have to sink. But in my case, I was very fortunate to have the first batch of students, two of them, Tushar Chakravarti and Vidya Bush. They were the first batch of students for me. And in the case of Tushar, it is even particularly important to mention, he was a student of MSc program, and IIT Kanpur MSc students were probably the best those days. In fact, practically in the class, every student who graduated, by the time they graduated, they all, of course, went abroad. Practically each and every student got at least 3-4 offers from the best of graduate schools in the United States, like Columbia University, Stanford University, Princeton, Cornell, things of that kind. But Tushar from that batch, for some reason, he did not want to go abroad. He wanted to do his PhD, although he had done his MSc project with me, but he didn't want to do his PhD, did not want to go abroad. That was rather surprising at that time. In fact, when Tushar opted to work with me, there are very senior people in the department, like Professor M.E. George, Professor Ranganathan. They were very established, well-known scientists at that time in the department. But he decided still that he would plan to work for me with a new faculty, very raw, very naive, a kind of an untested faculty in a way. And in spite of that, Tushar said that he will work for me. That actually was a turning point in my career, really. And that gave me a lot of confidence. So Tushar and Vidya, as the first batch of students, really helped me to kind of set up the lab, build up the lab, and carry out the kind of work that we were wanting to do at that point in time. After that, there is no going back for me. That is something which made a lot of difference for my academic career. And that is something which is remarkable. And in fact, not only did they do their work, both Tushar and Vidya, because as somebody pointed out, there are many students from MSc batch. They all would like to come and work in my lab for MSc project. And both Tushar and Vidya, not only did they do their work, but they also mentored, helped many of these MSc students in the earlier years. It was like, Sandhya Vishwesharaya, Niraja Pathasarathi, or Uday Maitra, or Arun Ghosh. They were all part of that group, MSc project group, where Tushar and Vidya mentored at that point in time. They helped me so that I could interact with these people. And that made a lot of difference for my career. And I also must point out, when I joined IIT Kanpur, Professor M.E. George was already there. He was a distinguished senior professor, organic chemistry. But he was the one who actually was a mentor for me at IIT Kanpur, right from day one until the day I left Kanpur. He was always very helpful. He went out of the way to do things for me and actually encouraged me to do my best. And that made a lot of difference again, because you need to have people to do this mentoring part. That is something, in my opinion, the present day system lacks the system. For a younger faculty, you need to have senior faculty to mentor them, help them, encourage them to do things. And that made a lot of difference for me at that point in time. Then, of course, I moved to Indian Institute of Science, Bangalore, in May 1989, basically because C.N.R. Rao was the director of the institute at the time. He wanted me to move, and then, of course, I agreed to move. And that again was a major turning point in my career, really. That was a good thing that I did at the right point in time, although not because I was unhappy with IIT Kanpur or anything, but this made a lot of difference to my career. I must also say, I was actually fortunate to have had the best high quality students who are dedicated, who are affectionate to join my group. Again, I must say, most of my students probably were smarter and probably even more intelligent than me, my opinion. I learned a lot of things from them, not the other way around. All the time when I interacted with my students, I learned many things from them. That is the truth. It is because of their excellence, dedicated efforts in the laboratory, that whatever little success that I could achieve was possible, in my opinion. I have to thank all of you guys, graduate students, postdocs, other co-workers, project assistants over a period of time in my lab. They all saw me grow. They all allowed me, helped me to grow in the academic system. That made again a lot of difference. Additionally, of course, apart from the institute, I had other people, senior professors, academic faculty from other institutions, who have been a lot of well-wishers for me, who were always willing to help me, willing to encourage me, willing to support me throughout my days. And then again, I must thank many of them for that. At this point, I will have to also say, probably come to my family. You know, my wife, Jayanti, my beautiful wife, she has been with me in this journey for over 45 years now. She had her own teaching career, and in spite of that, she took the full responsibility of the household completely and simply allowed me to spend more time with my students in the laboratory. I still remember I used to travel a lot. My kids were growing up, both Ramya and Aarti were growing up, going to school. I probably didn't spend enough time with them. Jayanti was the one who spent all the time taking care of them. And that I must actually thank her for doing everything so that I can concentrate and do things in my laboratory at that point. Now that I mentioned about my daughters, both Ramya and Aarti, beautiful daughters, we are very happy and very privileged to have raised two amazing girls. Girls who are intrinsically very independent and very affectionate and very professional now. They are very successful in their careers, whatever they are doing. Although in the early days when they were going to school, I probably maybe didn't have enough time to spend with them. Be that as it may, they still loved me. They still continue to love me. And of course, I also must take this opportunity to thank my sons-in-law, Mukund and Vayu, for their love and affection. And of course, I cannot finish my speech without mentioning about the most recent arrival in our family, our granddaughter, Kenara, our Aarti and Vayu's little princess. She arrived 2 weeks ago. And I really will look forward to seeing her maybe by end of this month, really next month. Love you, Kinara. Again, take this opportunity to thank Shivpriya and RGB for organizing this meeting online so that I could meet many people who during this so-called difficult pandemic time, they don't have to meet personally. But I'm happy this has been arranged. But I thoroughly enjoyed. As I said, it was a humbling experience for me. There are many things that were said. I do not know whether I deserve all the praise that you showered on me, but I accept them with humility. And thank you very much. All the best to you. Thank you.
Thank you, sir. Thank you, sir, for your kind and emotional words and spending time and gracing this event. And thank you, Jayanti ma'am, for spending so much time. And I think we all remember that. And we always seek, many of us would always seek your blessings. And we pray for your long and healthy and peaceful life along with Jayanti ma'am. Many, many more years ahead. And wish you once again happy birthday. Over to you, sir, Shiva.
Okay, so we have a special, one of our special lab colleague, friend, mentor, so Saravanan. He's an entrepreneur now, young entrepreneur. So we will leave the floor for him to wish sir as well as to thank everyone. Sarav?
Sarav, you are mute. Unmute.
Yeah. Am I audible now?
Yes, please. Go ahead.
Yeah, I would like to thank Sir. Happy birthday. And we wish him a long and healthy life so that he could witness the baton of his scientific legacy. More importantly, his humanity carried over to the future generations, especially his students, grand students, and his well-wishers. So, and also I would like to thank every Sivapriya and RGB for organizing this event, and Raja, Angamuthu, and Ganesh for making this technical aspects, and Ramesh as well. And the speakers of today, Dr. Professor Tushar and Dr. Balaji, for giving a wonderful lectures and initiating this lecture series. We definitely wanted to have this as a gala party as we did earlier in last 3 occasions, but due to the difficult situation of the COVID, we were not able to do that. In a blessing in disguise, actually we planned this year-long event, and hopefully if everything goes well, we should be able to meet next year with all of us. And it's really a wonderful thing to see that even the distance now with the technical advancements, we can all meet and we can interact with each other. So I'm happy to see even faces which I have not seen for a long time. And it's wonderful to see that. And finally, I would like to welcome the youngest member of the family, Kinara, and hope she shows us the new shows. And with this, I would conclude this one. I would like to thank all of us who attended this event, and we wish to see all of you again in future occasions whenever we organize the same meetings, and we would like to have a further interactions and hope we see each other soon. Thank you very much. Shiva, over to you.
Thank you, Sarav. It's been so wonderful, emotional, affectionate. So we all thank you for giving us a big family, sir. So seniors, juniors, summer interns. I think wherever we go in the world, we will have one of your student helping us in some other way. So and now we see whichever IIT or IISER, wherever we go, we first will go end up meeting our seniors or juniors. So I think that's a legacy that you have given to us, and very, very happy. So as RGP mentioned in the introductory remarks, that we will have a year-long celebrations. We will end up this meeting next 2021 on November 15, and hopefully we will meet everybody at that point. But every month there will be a special lecture. Already a few of very well-known professors have accepted to deliver a talk, including Professor V.K. Singh. So we would like to conclude this officially. If not everybody is hungry, some of you can stay back. If sir is not hungry to have his birthday lunch, I'm sure ma'am has made fantastic lunch today. So you can spend few more minutes. I'm sure Elanir Payasam or something special is there at home. We all miss it. So few of you can stay back sometime, if sir can stay back sometime. But officially, we would like to end the meeting now. And thanks a lot to every one of you. So RGB.
Yeah, I think everything is there. You have said everything. I will not say anything more. Thank you, everyone, each and everyone, sparing their times in spite of your busy schedule. Thank you so much for gracing the event and making this, this at least virtual meeting very successful. And we would love to have you again in the months or year, in the days to come. Thank you so much. Thanks once again. And once again, wishing you a happy birthday. See you.
So we can stop recording, and then if anybody would like to
stay back.